This is The Big Picture, an official television report of the United States Army, produced for the armed forces and the American people. Now, to show you part of the big picture, here is Master Sergeant Stuart Quaid.
At 10:48 p.m. Eastern Standard Time on January 31st, 1958, the attention of the American people was focused on Cape Canaveral, Florida, as a giant rocket was catapulted toward outer space. Few events in American history have been so awaited, prayed for, worked for, as the Army's successful launching of Explorer 1. Today's big picture will reveal the dramatic, suspenseful story of how the Army, when the prestige of the United States throughout the world had been shaken by events beyond its control, stirred the hearts and emotions of the American people with an epic display of scientific and technical teamwork. Our story starts 84 days before the launching of Explorer 1. The date, the morning of November 8, 1957, at Huntsville, Alabama. A sudden meeting has been called by General John B. Medeiros, Commanding General of the Army Ballistic Missile Agency.
Good morning, gentlemen. Be seated, please. I have a very important announcement for you. We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
This is what they've been waiting for. The deadline is 90 days. 90 days to put a satellite into orbit. A crash program, an emergency. And the American people had become aware of that emergency long before, when a Soviet Sputnik beeped its way across the skies. The reaction was one of astonishment and concern, for it was now known that a potential enemy was at least temporarily ahead in developing means for space travel. Reaction, counter-reaction. All at once, Americans were interested in the oncoming age of space, and with the curiosity came a mounting, swelling demand to get a satellite into the air on the double. But there were disappointments. It was an immensely difficult job, and the first American attempt with a Vanguard rocket was a failure. And that was the background for the assignment to the Army Ballistic Missile Agency on November 8, 1957. Put a satellite into orbit within 90 days. There was no sense of panic, as the capability for doing the job had been ABMA's since 1954. ABMA was a crack team headed by old pros of the missile field. Dr. Werner von Braun, director of the Development Operations Division, supervised over 3,000 scientists, engineers, and technicians with more years of practical experience than any similar group elsewhere. Long before a countdown starts at a launching pad, precise miniature replicas of the individual sections are made and subjected to numerous tests. And even the model work comes after a countless number of hours at the drafting tables. Each new experiment, each test means more knowledge, which may mean a change of design. There are often no precedents. It is creative work by creative men and women, absorbed in the fascinating problems of space flight. And it would be difficult to find a science which does not have something to contribute. Even as the research and design work, along with the incessant testing, goes on, the missiles take shape in the vast construction shops. In the development phase, no two missiles are alike. Each one contains changes and improvements on what has come before. All efforts are made to perfect the missiles quickly, but every day presents an obstacle course of unique problems. Even the welding, for example, involves special techniques needed to satisfy the very specific requirements of a missile. Now, added to the already numerous complications, the ABMA development team had the job of modifying an existing missile system for the purpose of achieving orbital capacity. The decision was passed down. Modify the Redstone ballistic missile, the Army's most powerful weapons carrier over a 200-mile range. Why the Redstone? It had proved itself again and again on the ABMA launching pads at Cape Canaveral, Florida. At Huntsville, Alabama, the steady success of the Redstone firings confirmed the feeling they were going to be the ones to put up a satellite. Work on modifications was accelerated around the clock. The tests of components, assemblies, everything that goes into the missile. Question: will a small piece of metal alloy withstand the hottest part of the rocket's exhaust? No guesswork. ABMA people have to know. The rocket's exhaust will be too much for the alloy. It melts. So they will develop a better one. But the final test at ABMA, the big one, where the results of thousands of tests are checked out, is the static firing. Held firmly in place, its rocket engines filled with fuel, the assembled missile is studied during full-force firing. In the blockhouse sheathed in concrete where the operating controls and personnel are located, the countdown has started. A few seconds before firing, the water is turned on. 4,000 gallons a minute are required to cool the flame deflector of the test stand in this simulated flight, where the missile will stay right where she is. The countdown moves along to the fateful moment. The static test is over. The rocket is taken down and dried out. A closer examination of the rocket by observer teams will determine how various parts withstood the static test firing. The static firing was successful, and the modified Redstone, which would serve as the first stage of the satellite-bearing rocket, was loaded aboard a plane. Stop, Cape Canaveral, Florida. But meanwhile, far across the country at the Jet Propulsion Laboratory, a sprawling 80-acre research and development complex in Pasadena, California, scientists and engineers were racing toward the same deadline: 90 days to put a satellite into orbit. Their job: furnish the high-speed upper stages to take over after the first stage powered the satellite to the prescribed distance from the Earth. JPL also assembled the satellite and provided instrumentation to transmit the scientific data. When completed, the cylinder contained 2 transmitters, their battery power supplies, and instrumentation for transmitting data on cosmic rays, meteorite erosion, and temperature measurements. The data would be dispatched continuously by the 2 transmitters. Assembled, the satellite appears small, but if all went well, 7.5 minutes from the time the giant missile bearing it would leave the Earth, the cylinder would be hurtling independently through space at a little over 18,000 miles per hour. If all went well. The checkout on the JPL test stand went smoothly. But only the launching pad at Cape Canaveral, Florida, would tell the story. The date, Wednesday, 29 January 1958. 8 days before the deadline set down by General Medeiros. On the morning of the 29th, the weather was not good. The prediction was for thunderstorms and unsatisfactory jet stream conditions aloft. A 24-hour postponement was decided upon. The hours passed with the rocket crews working swiftly, intensively. But there is a whole set of operations to be completed at least 24 hours before the countdown starts. It was not until Friday, January 31st, that the weather cleared sufficiently for General Medeiros to order launch at 10:30 p.m. Men worked on the lines, pipes, and servicing units on the pad. Others clambered about the various gantry levels. As is so often said in the Army, but rarely with more accuracy, this was it. Before the countdown was to start, the satellite and last stage rocket, shrouded to prevent even the slightest abrasion, was at the launching pad. Dwarfed by the giant missile and the protective scaffold of the gantry, the payload, weighing 30.8 pounds, 80 inches in length, is raised toward the top, where it will be carefully fitted into place, like a glittering jewel in a luminous setting. At X-2 hours, hydine, an exotic liquid oxygen oxidizer for the fuel, begins to flow into the tanks. Frosty white vapor hisses from the vents. Minutes click past relentlessly. The beams of powerful searchlights light up the missile. Truly the star of one of the greatest suspense dramas of our time. The drama approaches the final act, the Army's first attempt to fire a man-made moon into orbit. Time, late evening, Friday, January 31st, 1958, in a blockhouse at Canaveral. The countdown to Explorer 1.
Okay, we'll start now.
Finish fuel loading. Take a weight reading. Okay. Check the utility room fuel vapors and notify the blockhouse when we're clear to start generators.
Generator setting. Bob.
Control voltage on.
All right, 2.5. Program device on.
Gyros on. Gyro erection on. Check that launch loading has been completed. Roger. Connect assembly to igniters. Okay, tie down the leads. Roger, and install your protective tabs. Okay? Weight reading after last scaffold is removed. AFMTC telemeter calibration tape on. Start vibration and RPM recorders. Check all operating lights and meters for proper operation. Power panel check.
Power panel okay.
Control panel check.
Control panel okay.
Roger. Measuring panel check.
Measuring panel okay.
Roger. Cluster control panel check.
Cluster control panel okay, Bob.
Roger. Gyro erection off.
Gyro erection off.
Rudder drive on.
Rudder drive on.
Power transfer test on. Observe and record all voltages.
Power transfer test on. Voltage okay.
Power transfer off.
Power transfer off. Cluster clear for launch? Clear to launch. Bob? Yeah. 021, deflection of jet main number 2. We've either got a relay kicking out or there's something dropping down on the jet main instantaneously here.
Hold. Telemeter indicates that jet vane 2 is deflected. What do you want to do?
Forget it.
Okay, resume count.
Okay, shall we go ahead, Jim? It looks like that here. Roger. 50 seconds. 45 seconds, rudder drive on, destruct arm. Rudder drive on. Drive complete. All right, give me range safe, pad safety. Pad safety, range safe. I don't have it yet. Range safe. Range safe. Minus. APL telemetry recording on. Telemeter recording on. APL recording on? Yes. 20 seconds. Frequency 111, Terry. Roger, Joe. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Firing command. Firing command. Fuel tank pressurized. Block tank pressurized. Missile power. Ignition. Base tank. Lift off. Lift off. Quiet. Quiet. Tank command.
The missile is in flight, but the success of its mission is still in doubt. It will take another hour and a half to know whether the satellite is in orbit, the most tense and harrowing wait of all. Minitrack stations, throughout the world by the Army, Air Force, and Navy, followed the movements of the Army Earth satellite. At each of the stations, a Minitrack radio system received signals from a transmitter in the satellite. About midnight, not far from the now empty launching pad, General Medeiros finally called his assistant, Colonel Leonard Orman.
Hello, Len. You can send this off to the secretary. That our satellite is definitely on orbit. Now get that off, and then I'll give you the figures in a few minutes. Okay, boy.
In Washington, at the National Academy of Science, a packed auditorium of reporters, radio and TV interviewers heard the announcement of Dr. Richard Porter, chairman of the IGY committee.
The National Academy of Sciences and the National Science Foundation announced that as part of the U.S. International Geophysical Year program, a scientific Earth satellite was placed in orbit at 5 seconds after 10:55 p.m. by means of a Jupiter C rocket vehicle launched by the Army at Cape Canaveral, Florida. A similar statement is being issued by the President. And I should like to add my personal congratulations to the Army Ballistics Missiles Agency and to Dr. von Braun and Dr. Pickering and their colleagues for a job well done.
Before the news conference, the big picture camera and Sergeant Stuart Queen drew Dr. von Braun aside for a special interview.
Dr. von Braun, I wonder if you could tell our big picture viewers just what did transpire during those 84 days.
Well, those were rather hectic 84 days, I can assure you of that. A project like firing a satellite into orbit is only possible if there's splendid teamwork all the way through. In this particular case, this teamwork involved, at first, close cooperation between our own Army Ballistic Missile Agency in Huntsville, Alabama, and the Jet Propulsion Laboratory in Pasadena, California. Between the two of us, the vehicle was developed that carried the satellite into orbit. There was also very close cooperation between us and Iowa State University, which pioneered the payload. Jet Propulsion Laboratory also had a big hand in repackaging this payload for our vehicle, because this payload was originally designed with the Vanguard vehicle in mind as a potential carrier. Other groups that deserve much credit in our successful satellite try are the military and civilian personnel of Patrick Air Force Base down in Florida, from where the missile was fired. The range operation down there, and everybody from the command of the proving ground down to the last cameraman gave us splendid support. The tracking of the missile as it circles around the globe is in the hands of both IGY personnel and personnel of the Naval Research Laboratory. So you have an example here of splendid teamwork involving all three services, and I hope this example will show that you need not believe everything you hear and read about inter-service rivalry and its detrimental effects. There's actually a lot of fine teamwork between the services when it comes to getting things done.
20 minutes later, Dr. Porter opened the question and answer session by introducing three of the key men in the success story of Explorer 1.
Credit for the technical part of this achievement than any others in this country. First, Dr. Werner von Braun, Director for Development, Operations of the Army Ballistic Missiles Agency. Dr. von Braun, would you rise, please? Dr. James A. Van Allen, Head of the Physics Department of the State University of Iowa, who is Chairman of the Working Group on Internal Instrumentation of the Panel for the Earth Satellite Program. Dr. Van Allen. And Dr. William H. Pickering, Director of the Jet Propulsion Laboratory of the California Institute of Technology, Chairman of our Working Group on Tracking and Computation. These three gentlemen have all had a direct and important part in this achievement. Now, if you would like to address your questions, I will try to repeat the question, and we'll ask the one of these gentlemen best qualified to answer it for you.
How many stages in the device?
Dr. von Braun, how many stages in the device?
We have a total of 4 stages. The first stage is an elongated Redstone missile. You kindly show it, Bill. An elongated Redstone missile with extra long tanks and a special fuel combination, which burns for approximately 140 seconds, 145 seconds. Immediately after cutoff, we separate the front portion of this missile, the so-called instrument compartment, from the tank section. This instrument compartment is equipped with a spatial attitude control system, as we call it, that aligns this portion, including this spinning launcher in the nose, into an exactly horizontal position. Once this nose section with the spinning cluster configuration in the nose goes through the apex of the trajectory, the top stages are fired. And there are 3 solid rocket stages in the top. So it's a 4-stage vehicle.
How does this altitude compare with the Sputniks?
This is somewhat greater than the altitude of either Sputnik 1 or Sputnik 2.
The question is, has any form of life been placed in the satellite? I think I could answer that one almost myself. Not intentionally.
Maybe we have a Florida cockroach inside. We don't know.
Everybody welcomed the touches of humor, for it was, after all, an hour of jubilation. Just one more, came the inevitable plea from the photographers. And exhausted as they were, the trio obliged with what was to be the page one spread in newspapers all over the world. In plain language, the United States was in the space business along with the Russians, and Explorer 1 was the beginning. Just under 2 months after Explorer 1 was put into orbit, and close on the heels of a successful firing of the Navy's Vanguard, a launching pad at Canaveral awaited another Army satellite, Explorer 3. The Army's first success had not washed away the rocket men's humility, for there are a countless number of things that can go wrong in the operation. And indeed, Explorer 2, fired successfully, had failed to go into orbit because of one tiny component in the last stage. Maybe that was why along the Florida beaches, many fingers were crossed as eyes stared toward Explorer 3. Shortly before launch, the upper stages are set rotating. If the spin were not provided, the payload would be hopelessly deflected. Explorer 3 was reported in orbit. Again, news flashed instantaneously throughout the world, in every language, to every country. And wherever the news went, it had an effect of transcendent importance. The scientific and technical prestige of the United States was enhanced. People everywhere knew the free world would not be left behind in the all-important race toward outer space. Now, Americans could once again look up toward their future with faith and with confidence.
And so 2 explorers were in orbit. Momentous achievements made possible by the close cooperation of the Army with some of the best technical and scientific minds in the land. As these satellites raced through the uncharted upper atmospheres, there would come a steady stream of information to enrich our knowledge of the worlds about us, the infinity that lies far, far beyond the wild blue yonder. Now this is Sergeant Stuart Queen, your host for The Big Picture.
The Big Picture is an official television report for the armed forces and the American people. Produced by the Army Pictorial Center. Presented by the United States Army in cooperation with this station.